Yeah, thanks for the introduction and thanks for having me. So in recent years, there's been a general trend, just similar for running applications, to also build applications in a way where you don't have your one only snowflakey build server, but instead you do a container-based approach where every job, every build job, every test job gets its own container, and then they can all work in parallel nicely next to each other on a CI server. So what this gives you is, of course, obviously, you get a clean environment for each build. You can recreate it reproducibly. And you also get some degree of isolation there. So actually, let's do a quick poll regarding CI tools, so stuff to build and test your code, not so much deployment. Who of you uses GitHub Actions? Few, yeah. GitLab CI? Many people, yeah, that's nice. What else do we have? Jenkins? Yeah, some Jenkins people, about the same amount as GitHub CI, GitHub Actions, I'd say. Circle CI? No one? Something else? Something I missed? Okay. Drone CI is what I hear. Yeah, okay. But yeah, if you're familiar with GitLab CI, you might very well be familiar with this pattern because it's a very common way to run jobs on GitLab CI. And but this is also getting more and more common with tools like Jenkins or Circle CI, where you can also have a similar pattern of CI jobs as containers. And then if you're, of course, already doing that, you might, of course, go the full way and deploy the workloads into Kubernetes. So yeah, distribute your CI jobs across the Kubernetes cluster. And yeah, just run this in the cluster without having a dedicated build server. OK, so this is all nice. But now you just don't want to build and test your applications. You also want to build container images. And ideally, what you want to have is this, right? You just want to have the CI server. You want the CI job as a container on it. And then within that, in a nested fashion, you want to build your new container image. However, for reasons we'll get into, this is not really possible easily. So what you typically do instead is what's recommended by GitLab CI, for example, is one of two things. You either use Docker in Docker with a privileged container, or you just mount the Docker socket from the outside Docker daemon to within your build container so that the image build container can then be spawned parallel to the build container. And both of these things are quite terrible from a security perspective because it's trivial to escape in both of these scenarios. And then you escape the build container, and from there you can basically compromise the whole CI server. So if you're still not convinced why this is bad, well, build servers in general, they're a very high-profile target. It's really easy to compromise all the builds and elevate your privileges from there. And so we also have this article by NCC Group, which is a security consultancy, about the 10 real-world stories of how they've compromised CI/CD pipelines. And right there, as attack number 5, you have GitLab runners using privileged containers. So yeah, this is kind of an issue. You might argue, well, the privileged code is only the CI definition, so the Docker build command, and not what's running within the image build, so the contents of your Docker file. But still, depending on the environment you have, especially if you have a shared build environment shared across different teams, this might still be a big issue. And just as a general architecture point, a single build job just shouldn't be able to compromise the whole build server. That's just not how it should be working. OK, so let's look at why we can't just run Docker build within a container. And I'm not exactly telling news here. This has actually been discussed quite a lot in the past by these people here, including right here at ContainerDays. The general problem is that in a lot of ways, this comes down to running containers within containers in a nested way. And this is never easy to do. And we'll see why in a few minutes. If you look at this list of articles and talks, you'll see that most of this happened a few years ago, so around 2018. There was a lot of traction around this topic back then. But now, and it wasn't really, there was no ready-to-use solution back then. But now, I mean, 6 years have passed, the whole pandemic has passed. So I ask myself, well, can we do better now? What has changed since then? And yeah, we'll find out about that in a few minutes. But on the next 2 slides, I'm first going to introduce you to the problem in general. So if you want to learn more about the problem, have a look at these resources. But I'm also going to cover the most important aspects. So our first and most important issue, when we already have set up our build container for the CI job, is that we need, in order to spawn that second container-like thing, that image build environment, we need some privileges that are root or at least root-like in Linux. And of course, we don't want to give these to the build container, which would be a privileged container. But I mean, the reason we're talking about is that we don't want a privileged container in the first place. So the major building block to work around this is user namespaces in Linux. So you viewers has heard of, or is at least somewhat familiar with user namespaces? Yeah, I'd say a third maybe. Okay, I'm going to give a very quick introduction to user namespaces. So user namespaces are this Linux feature where you can be root in some isolated part of the system, but outside of this isolated part, it maps to an unprivileged container on your host. So you set up this namespace, you gain routing access in there, but only in there. And from there, you can then do things like set up additional namespaces which are bound to that user namespace, do things like change root, pivot root, all things you might need. This means you can change the image build. You can then set up the image build within that user namespace. However, to the outside world, you're still an unprivileged user. And for example, if you have mounted directories and create some file, it will still be owned by that unprivileged user from the outside. So how does this map to our use case? Well, the idea would be that the host is the CI server with the initial namespace. And yeah, we then establish a user namespace for our build container. And within that, we can then set up the image build. And it might be an additional user namespace. It might not be. I don't really care too much about that. The important thing is that we have user namespaces for the outer container, if you want, for the build container. In order to use user namespaces, they need to be enabled at the kernel level. So there's, for one, a build option. There are also most distributions add some runtime syscontrol option. So what this does, it allows a regular user to create such a user namespace and then become root within that namespace. Otherwise, you could just move from root to root, which would be kind of pointless. And then, of course, you also need support from your container runtime for user namespaces. But good news is that, first of all, most container runtimes are supported these days. And second, also this right here is enabled on most mainstream distributions. Okay, so are we good to go now? Can we just use user namespaces and build our container image? Well, no, of course, there's more. And we also need to establish a new file system for this image being built for what we want to build. It just needs an initial root file system. And if you root in a user namespace, you can mount some file systems. But nothing we have up here really helps us with setting up an initial root file system. This is all just special file system types, which are not useful for setting up the root file system. So that's why some distributions added Fuse support, so file system in user space support at some point. Patch for that was also upstreamed at some point. And if you look at these older resources or some other articles, you will find that people tend to like to use Fuse for this purpose. However, since kernel 5.11, so also quite some while ago, there's another option which I prefer, which is actually using overlayfs. So it's pretty cool. Actual progress has been made in this regard in recent years. And we can just use overlayfs, which is what we would use anyway, also if we weren't doing this nested container thing. And yeah, that's cool. Once again, are we done yet? Well, still no, because we also need some pseudo file systems such as Procfs. And you might think, well, Procfs is in this list. It's named /proc here, but it's the same thing. So everything should be fine, right? Well, once again, no. Because so first of all, if you're not familiar with Procfs, well, Procfs is a pseudo file system in Linux, which typically gets mounted at /proc. And it provides you with information about your processes on your system and also the system in general. Why do we need to mount this when building a container? Well, we typically also get a new PID namespace. So we get PID 0 for the process within the container image being built. And we need to mount the corresponding proc system in order to basically have the right process IDs there. So what you see here is some proc-related mounts in a typical Docker container. So we start with just a regular mount of the Procfs file system at /proc. That's cool. This is what we would expect. But then we get some more mounts, which is like this. So what is this? Well, in Procfs and Linux, you not just have things related to the PIDs, but you also have some very special files. And these files are singletons. So they're not namespaced, but they're global to the system. So you get within proc the PIDs, which are namespaced and only local to your container. And then you get this list of stuff right up here, which is things that are not isolated from each other. And for example, if you look at proc sysrequest trigger, this is what you could use to reboot the whole system. So actually the host without any isolations. So you don't want this, and that's why this is mounted as read-only above the regular rootfs, so that you can't write to it. And then it gets even worse, because we have some files which you don't even want to allow to read. For example, proc kcore would give access to the whole system memory. And these are then completely hidden. So something's mounted over them, you can't just access them anymore. How is this a problem? Well, it's problematic because when we want to assume this is our CI job container, our outer container, and now we want to establish the image build, that inner container. And we cannot just mount a new Procfs there because we get this error message. And what this tells us is that, well, if you don't even have access to a whole Procfs to begin with, because the shadowing is there, you can't mount a new Procfs, not at all. So the kernel only allows you to mount a new Procfs if the old one is already completely visible, and we don't have that in a container environment. What can we do about this? Well, first of all, we can go ahead and disable that masking. And you might feel like, well, this is weird. It's a security option. We disable it. Is this a good thing to do? Well, I agree that it feels weird, but it actually looks like this is the cleanest solution if we already have user namespaces. So this is the important point here. This masking is important if you don't have user namespaces. As soon as you have user namespaces, these already do quite some isolation for you. So it looks like it's actually safe to not do any masking as long as you're running with user namespaces. And yeah, you can set this as a Docker option. You can also set it with Podman. There also is a Kubernetes option for it, which appears to be behind a feature flag. I didn't try that one myself. I assume it also needs support from your container runtime there. But yeah, I have the docs right here for Kubernetes. And yeah, unfortunately, as I just found out very recently, you currently can't do this if you're using GitLab runner with the Docker executor, because you just can't pass this security option to the Docker daemon, which is a bit of a shame. There's an open issue to it. But yeah, this is a limitation we currently have to deal with. So instead of disabling it, what you also might want to think about is, well, this is kind of a bad design, having these global singleton files in Procfs. And can we do something about this in the Linux kernel? Well, shout out to Alexei Gladkov here, who proposed quite some different solutions over the years. Unfortunately, none of them really made it into the kernel except for one of them, which is the subset equals PID option. So that one is available since kernel 5.8. The thing with that is, well, it's really, as the name says, PID only. So now you just get process information in /proc. You don't get access to things like Kcore, which is good, but you also don't get access to critical stuff like CPU info or mem info, which your applications might need and which are non-critical to access. So this is also not ideal. And I mean, the more important thing, this would also require support in container runtimes to set up the containers like this, and that is just not there. So yeah, it's a nice idea. But the more I think about this, I feel like the right way to go is just disabling the masking, because you don't really need it with user namespaces, and not deal with any kernel changes. Okay, so I stopped somewhere at the challenges. Do we have other challenges? Well, not inherently, but there are some other things you might have to consider depending on your runtime, which is syscall blocking through seccomp. You can also just disable this, and then mandatory access control with either AppArmor, or for Podman it can also be SE Linux. Is it fine to disable these? Well, these are more defense in depth or hardening mechanisms in general. So the security doesn't depend on them in the first place. It is nice to have them, but it should also be fine to disable it and not be immediately exploitable. And yeah, if you really want to get into it in more detail, you can also add some custom profiles or custom labels and adjust the settings you have there for the syscalls and the accesses you need. So with that, I'm happy to announce that we have actually solved all our challenges. And we can now set up this image build nested within a CI container. And we'll see how to practically do this in a few minutes. But let's first discuss some bit more whether this is actually secure. So everything we discussed relies heavily on user namespaces, and to be precise, the fact that user namespaces can be created as an unprivileged user. And this is something that has been supported in Linux for quite some while, but as it turns out, it can lead to quite some dangers. So, I mean, even if the scope of your root is supposed to be limited to that namespace, you have tons of other Linux kernel code that used to be written in a time where there was just either root or not root. And now we introduce something which is, well, root in some places, but not in others. And this has been a constant source of vulnerabilities for quite a while now, because every now and then some new part in the kernel pops up that just doesn't handle this correctly. So I have a list of some vulnerabilities from 2022 up there. Some people, as this person from the Debian bug tracker, doesn't trust user namespaces at all. It appears to have gotten a bit better with less vulnerabilities popping up, but then we had this NF tables related one quite a few weeks ago. So yeah, I totally understand if you don't want to trust this. So that might probably mean you need some other level of isolation using VMs, not using shared runners at all, whatever. But compared to what we saw previously with either Docker in Docker or hosting the Docker socket from the outside, this is at least conceptually secure. So relying on user namespaces might not be the most secure design, but it's still better than just giving the access in the first place, because in order for this to be insecure, you do need additional vulnerabilities. And even though the attack surface is quite large, you need vulnerabilities to begin with, 0 days if you want so. And the other thing is just inherently insecure. Another term you see come up quite often in this context is talking about rootlessness. And rootlessness refers to the idea of running both the container runtime and the containers without any root privileges. So how does this relate to what we're talking about here? Well, I mean, rootlessness is not my goal by itself. I more care about practically building containers within containers, and with or without root, I don't really care. But it turns out that many of the same challenges do apply here, whether you want a rootless container builds or you want these nested container builds. So generally, if you already have the tools for rootlessness available, it's also easy to run this in an untrusted environment. That's it for the theory. So let's now have a look at how to do this in practice. So I'm going to be talking about some tools you might want to use. And yeah, at this point, we kind of deviate a bit from the idea of running containers within containers, because truth is, we don't really need to launch a full-fledged nested container within our CI container. This is still similar challenges, but a bit harder. But in order to build a container image, we don't need a full container. We need, like, I would say 90% of that maybe. So we can use some more lightweight build tools for that. And we're going to do just that. And for the following slides, yeah, this is going to be the environment I'm using. It's pretty much a regular Docker setup, with the one exception that user namespaces are enabled. So the rest is default. User namespaces have to be explicitly enabled in Docker, but you can just follow the guide from the documentation right there. Okay, first tool. First tool I'm going to talk about is BuildKit. So BuildKit is from the Docker project itself. In general, it's more of a component than a standalone tool. And today is the default implementation of Docker build. So if you run a regular Docker build command, this is using BuildKit internally these days. But you can also use it directly through a tool called build control, which is delivered with it. And they even have a doc for how to do it in a rootless way in their repo. So this is what I adopted. And what we do is, well, we have on our outside host, in this example, we have some Docker file. And then we start a BuildKit container. We disable the security options as we previously discussed, and we mount our current directory with the Docker file into the container. And then we have this container running with the BuildKit daemon in it, and then we can exec into it and run build control to perform the actual build. And we tell build control, well, okay, we have a Docker file, and in this case, please output this to a Docker tarball, but you can also just push it to a registry, generate an OCI image, whatever. So much for BuildKit. The other thing I would like to show is Builder. So Builder is somewhat similar to BuildKit, but it's more from the Podman Red Hat world. Similar to BuildKit, it's also what is being used to implement Podman build. And but Builder is more standalone, it's daemonless, and it can also be, it's also designed to be used as a standalone tool, which is what we're doing just there. So once again, we run a container with these options. This time we don't need to exec in it because there's no daemon run it. We can just get the shell in the container and then do our stuff there. However, what we need to do is adjust the config through these set commands. So what is this about? Well, as I mentioned earlier, it was somewhat common to use Fuse, user space file system, instead of overlayfs. But these days, I prefer to use it without Fuse. And the container image I'm using here comes pre-configured with using the Fuse driver for file system stuff. So what we do is we actually just comment out the options, configuring it to use Fuse, which then goes back to using regular overlayfs, which is what we want. So interesting enough, if you use some older guides, they will tell you to explicitly enable Fuse. Now the image comes pre-configured with it, and we have to disable it again. But yeah, so much for Builder. And what you can do with both of these tools I just discussed, BuildKit and Builder, is vary how much isolation you actually need or have. So remember what I told you about this Procfs masking and the fact that we have to launch a new Procfs for our new PID namespace, but we can't do that because the old one is masked. Well, you can also work around that by just not doing any process isolation between your build container and the image being built. So this is enabled by both BuildKit and Builder. And what it basically does is, well, you don't have to do the security opt system parts unconfined Docker option or equivalent for other tools. But you launch your build tool with one of these options. And therefore, you trade more isolation between the host and your build container, your CI job container, for less isolation between the CI job container and the image being built. So that might be depending on your environment and what you can put there in terms of configuration, that might be a trade-off you're willing to take. Be aware that the builder option just doesn't disable PID namespaces, but also C groups, networks, and IPC namespaces, which is something to keep in mind as well. But it might be a trade-off you're willing to take. And one reason why you would be willing to take that is the limitation I discussed previously with the GitLab CI Docker executor. So as I told you before, we currently can't configure system paths unconfined there. But what we can do instead is use, in this example, builder with change root isolation. So we have a bit of a runner executor config for the GitLab runner here in the top, and then lower one we have our CI job definition. And you see once again we changed the config to use overlay FS, and then we just run the build. So these are the two tools I would recommend at the moment. I want to talk about some more tools, even if I wouldn't really recommend them anymore. So first we have IMG or image by Jesse Frazell. This really was one of the earliest showcases for doing unprivileged container builds. Active deployment seems to have kind of stopped. I managed to get it running somehow, but I will just say there are better options these days. For example, just using BuildKit directly, because image is based on BuildKit. Similarly, we have Orca Build, which is the project by Alexa Sarai, also someone who has done quite some work around the whole unprivileged image space theme. Don't confuse it for the other tool being called Orca Build. Naming is confusing. This also seems more like an early tech demo to me. Development only went on for about a year. And I got it somehow running, but I encountered some strange errors. And let's say it's not the go-to solution anymore. Then we have Stacker by Cisco, supposed to be a declarative alternative to Docker files. Declarative in this case just means putting a bunch of commands to be run in a YAML file, so you can call that declarative or not. It can run unprivileged with some limitations, but it's kind of hard to get running, and really it's kind of its own world, not using Docker files, but just doing its own thing. One more tool which is also living in its own world is the whole chain guard world with Upco and Melange. These are relatively recent. You might have heard of them. So Upco is a tool to build container images in a completely declarative and reproducible way. That one can run unprivileged. But then if you want to run any custom install commands, I don't know, pip install or anything, you do that by resorting back to some very basic package management. So you create a package using some other tool called Melange. And then you, once again, in the declarative way, take that Melange package and install it in your container using Upco. And the Melange build part doesn't work unprivileged at the moment. And then, of course, we have the elephant in the room, which is Kaniko. So if you're wondering so far, well, where is Kaniko in this? Right here at the end, because now we're talking about it. It's quite a popular tool, originally open sourced by Google. It seems like the current go-to solution for a lot of people if they want to build container images in an unprivileged way. And what it does is, well, it doesn't just bother to do any isolation, but it just mixes the file system of the image being built with the one of the build container and not doing any kind of isolation between these. And then doing just a file system snapshot. So no mounting, no namespaces, no nothing here. The problem I had with it was that I encountered some very strange bugs related to file system permissions, file system ownerships, all of that. And Kaniko doesn't seem that actively maintained. At least nobody was interested in these bugs for a very long while. So this was part of the original motivation for this talk, to find an alternative to Kaniko. So did I succeed in finding that alternative? What's it like in 2024? Well, I will say all the building blocks are in place now, a bit better than in 2018 even. What's lacking is mostly some documentation and maybe some better tooling. And then it's, of course, annoying that you still have to deal with stuff like this GitLab runner, can't set this config option kind of stuff. So in general, if you want to adopt this, my current recommendation would be using Builder, maybe also BuildKit if you prefer that. I am excited for what tools like Upco will bring us in the future, but at the moment, as I said, it's not possible to use that one unprivileged. And in general, regarding the security, well, you just have to decide for yourself if security guarantees of user namespaces are good enough for you or not. So with that, I think we have some time for questions. Thank you.
Thank you, Felix. So there was a bit of a wait for Canico dimension, because I think many people are interested in your opinion. Me personally as well, you mentioned there's no isolation in Canico. So can you expand that on a bit?
Yeah, so what Canico does, it just takes its existing file system of your build container, of your CI job container, and it has some special mount points like /Canico, which you typically wouldn't have in another container image, and then it just takes your base image of your image build and mixes it all together. And then at the end, it just looks at what files have changed and does some kind of snapshotting there, and of course removes its internal parts like that /Canico1. So that's in terms of file systems, and in terms of processes and other isolation you might have, it just doesn't do any.
So you see it as a security risk, or?
It depends on your threat model. So, I mean, it's only about isolation between the build container and the image being built. So this is kind of similar to the discussion we had about isolation change root with BuildKit or Builder. But it does give you less isolation than any of the other tools.
I understand. All right. And then back to Builder and BuildKit. Any difference between the images that they build?
I mean, in details, probably, but these are all compatible, OCI-compatible images, which are being emitted from these tools.
Yeah, so they should be functionally the same. Yeah. All right. If you have more questions, submit them on Slido. Otherwise, just wait a couple of seconds. Oh, yes, another one.
Any ideas on how to deal if there are many existing workflows by app teams that use Docker? Any ideas on how to migrate to Builder? Well, I guess what this question is getting at is you already have a lot of privileged CI containers running currently or mounting the Docker socket, and now you want to move to unprivileged runners. So that's at least a challenge I can think of. Yeah, I guess at some point, if you're the one maintaining those runners, you just have to phase out support for the privileged way and tell people how to do it differently. Or tell people to have their own CI runner where they can do whatever you want. It depends on what your role here is as a platform engineer or as a software developer or whatever.
All right. I think we answered all the questions. So thank you very much, Felix.
Thank you.